Welcome to the special talk. This talk is designed for microwave physics and applications, as well as electrodynamics. My name is Chunxu Zhang from Department of Physics, National Tsinghua University. The topic of my talk in Chinese is 光速的调控。群速度可以大于光速吗？ That will be group delay control. Group delay, I will explain very soon. I will talk about novel superluminal mechanism. This mechanism with high transmission and broad bandwidth. What is superluminal? Faster than the speed of light. Therefore, we give it another name. We try to understand this mechanism with another term, group delay. Okay, first, I would like to claim this phenomenon we present here do not violate the special relativity, which is a cornerstone of the modern understanding of physics for more than a century. So don't worry. Einstein should be happy, even though group velocity faster than the speed of light, as well as phase velocity. Okay, so the outline of today's talk is shown here. And we will first introduce some faster than the speed of light effect called evanescent wave. And I will compare matter wave as well as EM wave. They look very similar in properties. And then I will introduce a three-dimensional effect called modal analysis. So quantum mechanics as well as electrodynamics will differ because of modal analysis. Then I will introduce a new superluminal mechanism, and it's propagating wave, not evanescent wave. Later on, we can manipulate the group delay, control the group delay, and finally, we will give you a conclusion as well as acknowledgement. Okay, human being, the fattest person is Usain Bolt. The speed is about 10 meters per second for human being. No surprise. Sprinter, Jamaican sprinter. How about car? Car, of course, can run much faster. So speed record unofficial is roughly here 150 meters per second on the ground. On the air, this is a SR-71 Blackbird, hold a record of close to 1,000 meters per second. Pretty good, but still not good enough. How about space shuttle? Space shuttle, when they re-enter the Earth's atmosphere, they reach a top speed 7777 meters per second. Quite high, but still not high enough. For large object, it cannot exceed the speed of light, that's for sure. How about for small object, very, very small object, like electron? Electron, the Large Electron-Positron Collider, LEP. Highest particle speed, LEP, is one of the largest particle accelerator ever constructed. And the energy is roughly about 200 GeV, and gamma factor 200,000. So beta is shown here, 0.9999999, 10 digits. But just millimeters per second slower than the speed of light. Even the electron cannot exceed the speed of light. So it's clear matter cannot exceed the speed of light in vacuum. It set an upper limit. How about wave? Yeah, matter cannot exceed the speed of light, but wave. Look at this case. We learned in Jackson chapter 7. It's a superluminal mechanism, anomalous dispersion. For example, we have a index of refraction, N, is a function of frequency. No surprise. So index of refraction is C times K over omega. So in this case, phase velocity is defined as omega over K. So it's C divided by N. Therefore, phase velocity can faster than the speed of light in this region. No surprise. And group velocity is the omega over dk. So index of refraction times omega. We learned this before. So group velocity also can exceed the speed of light in this region. Therefore, we give it another definition. We have another definition called group delay. The phi over dk. Phi is the phase. It's just k times L. So it's L divided by Vg. So we can express as group velocity all in terms of group delay. Group velocity faster than the speed of light is not comfortable for many researchers. But group delay, it can be positive, can be negative. Don't worry. Yeah. Look at this case. Anomalous dispersion was observed. Is observed in a dielectric medium, such as this is a generalized dielectric constant, and for bound charge, for free charge. And for dielectric material, we know the free charge is very small or zero, so it's negligible. So when omega is very close to the binding frequency of this group of electrons, epsilon exhibits resonance behavior, okay? And we have anomalous dispersion. Okay, close to zero here. Look at this case. Our major result. Polyamides are semi-crystalline polymers. The data was measured with a time domain spectroscopy, terahertz TDS system. Okay, here, anomalous dispersion. But you can also observe an effect. The attenuation constant surge to a very high value. Oh, just a moment. Surge to a very high value, just like this case. So wave cannot propagate. It's resonance absorption. It's evanescent wave. Look at this case. For quantum mechanics, we learned this one before. Potential barrier with the barrier high V, and the energy of the particle is E. In this region, this is negative. So velocity will be imaginary. However, luckily, for the microwave propagating in a waveguide system like this one, 3-section waveguide, and cutoff is much higher here, wave cannot penetrate. So it's analogous to the behavior of a one-dimensional matter wave. Compared to the matter wave, obviously this system is much easier to implement. So we can measure the group velocity with this system. No surprise. Okay, in summary, anomalous dispersion and tunneling effect are the two major mechanisms for the superluminal phenomena. But don't worry, wave cannot propagate. It's just evanescent waves only. So even though faster than the speed of light, we don't have to worry too much. They just evanescent wave cannot propagate inside the region of interest.